Hello everyone, in this video we're going to discuss the implementation of ls-l command. ls command is used to display the contents of a directory, that is the files and folders listed in the directory. So the -l option along with ls displays detailed information about the files and folders in the directory. So what are the detailed information is, here you can see this is the output of an ls-l command, and this information that is displayed here contains 8 different information about each of the file and folder in that particular directory. So the first one is the first column that you see here, D, 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 D and dash. This indicates the type of the file. So Linux operating system basically categorizes the files into different types: a directory file, a regular file, a link file, a FIFO file, character device file, block device file, and so on. So depending upon the type of the file, it is categorized, and the first character indicates the type of the file. So here D indicates directory. So this article underscore images is a directory file. And here in the last case it is dash, indicates it's a regular file. So this cloning is a regular file here. So the first column here indicates the file type. The second information is this set of 9 characters here, what you see, RWX, RWX, R-X. So these indicate the permissions for the file. So R stands for read, W stands for write, and X stands for execute. So we are repeating this pattern 3 times here because it's represent the read, write, execute permissions for owner of the file, for the group owner of the file, and for others. So what is owner? Is the user who created the file is called the owner of the file. Now what is the group owner? Is sort of users can be grouped together into a concept called group. Okay, so a set of users can be grouped to form create a group, and all the files in that particular group and all the users will have the same set of permissions for the files in that belonging to that particular group. So if there's a set, there's a project and a set of users are working on the project and they need to share the files, in that case the group can be created and the permissions can be defined for the group owner of the for the files belonging to that project. Now so that's about owner and group. The user who is neither the owner nor the group owner will be treated as others, and this set of permissions, the last set of permissions, are used to check whether the person is authorized to carry out that particular operation or not. For example, if I take this example of cloning, here this cloning is a file, and others, the person who is the user who is neither the group owner or nor the owner of the file can only perform the read operation on this cloning file. He cannot modify or he cannot execute that particular file. So this set of permissions are used whenever the files are accessed. So this is about the permissions. So it displays the permissions of the file. The next, here you see the number 35241, right? So this indicates the hard link count. So what is a hard link is? Hard link is the path name of a file. So basically a name of the file. So a file can have more than one path. So a single file can be accessed from more than one path. That is called as a hard link of the file. So here, for example, this article images directory has got hard link count 3. What does that mean? Is that particular directory can be accessed using 3 different paths or 3 different names. So usually the directory can be accessed using the directory name and using a dot and a double dot. So that's the reason here it is 3. So the hard link, to summarize, hard link is the path name for the file. Okay, so a file can have more than one path name. So it represents how many paths the file particular file has got. Okay, next, after this hard link count comes the owner name. I told you owner is the user who has created the file, right? And then after the owner name is the group owner name. Okay, so group is a set of users can be clubbed together to form a concept of a group, right? And the group owner can be defined. So this is the group. The next number that you see here, 4096 and 0 and 16384, this is the size of the file. Okay, size of the file or the size of the directory. Next, this date and time, this represents the modification, last modification time of the file. Okay, and then the last information is the name of the file. So when I execute ls-l, then it represents, it gives me this output, wherein with this output with respect to each of the files and directories present in that directory. So it's going to display these 8 information about each of the file and directory that is present in that directory. Right. So now in this particular video, we are going to discuss how we will implement this ls-l command, implementation of the ls command. So this particular implementation is going to use these set of system calls here: opendir, readdir, stat, getpwid, getgrgid, local time, and strf time. So here opendir. So as you know, ls, it's going to display the contents of the directory, isn't it? So directory is a file, right? So first thing is we have to open that particular file. So opendir is used to open a directory. Once we open the directory, we have to read the content of the directory. Directory is a file, right? So it's basically a record file, and we have to read the directory content. So directory, as I told you, it's a record, and when you read a directory, you're going to get the a directory, as I told you, it's a record, right? It's a record file. So the record contains this information: the inode number, the offset to next directory. So let's not go into details of this. So a directory contains a record which has got these columns: inode number, offset, length of this record, the type of the file, and then the file name, right? So we read the directory and we get this file name from that record. Okay, and then the next one is stat. Stat is used on the file name. Once we get the file name from the directory that we have read, after reading the directory we get this d name, right? Then we perform stat on that particular file. Stat gives the statistics of the file. So this stat system call gives you this set of information about that file. So here you can see the structure. If you look into the structure, it has got so many information: the device ID, inode number, stmod, mode, and the hard link count, user ID, group ID, and so on. So when we execute stat on the particular file, we get all of this information, and this set of information is sufficient for us to implement the ls-l command. So let's look into it one by one. So then we have getpwd. So here when we use from this stat, you can see here we are going to get this from using this member. We are going to get the user ID of the file, and also from st_gid we are going to get the user ID of group ID of the file. So but we want here name. We have the number ID. Okay, we want name. So this getpwid is going to convert the ID into this name, and getgrgid is going to convert that ID into name. Okay, and now this next is size. So size, here you can see we can directly get the size. We will see into the implementation. And then we have local time. So this local time is used to local time and strf time are used to print the modification time in this particular format. So these are set of the system calls that we are going to use to implement the. So here you can see we have included different header files. These header files are required by the system calls that we have discussed earlier. To start with main, we are first declaring a directory handler. So opendir function, which opens a directory, returns a pointer of type dir star. Then struct direct. So directory is basically a record file. So each record is of type struct direct. So it stores these informations you can see here. And when we read a directory, it returns a pointer of type struct direct, which contains the informations that we have seen. Then struct statbuf, we have seen struct stat. So struct stat basically contains multiple information related to a file. So when we call stat, it returns these informations. Then we are declaring ij. Here Next we have a permissions string. So you can see P is a string we have initialized to RWX, basically the standard set of permissions. During the program, we will determine what permissions are there and what permissions are not there. Accordingly, we'll copy the permissions from P, and which are not there, we will replace it with dash. Then we have struct password, struct group. These are basically used to convert the user ID and group ID to username and group name. Then we have struct tm. So this is for the time, and the formatted time will be stored in the string time. So to begin with, first thing is we are opening the current directory. So the opendir function, it returns a pointer of type D. So this is D is given as an argument to read dir. Read dir reads the first record and returns a pointer of type struct direct, right? And we are going to continue this while loop. In the while loop, we are basically extracting the we are basically printing the output of ls command, right? So we are going to do it for each and every file in that directory until we reach the end of the directory. So when read dir returns null, it means we have reached the end of the directory. So we are continuing to read the directory until we reach null. So when we read a directory, it's returning struct direct type. So that structure has a member D name, which gives the file name, right? So we are calling stat on that file name, and we are fetching that struct stat buff we have seen here, right? So here you can see D name is the file name, and this is the struct stat, which the stat function returns information about that particular file. So now in this structure, one important member is st_mode. It contains file type and file permissions, right? So if you recall, the output of ls, the first is the file type, right? First column is the file type. So in this part, we are extracting the file type information from the file. So as discussed, st_mode contains the file type information. So here this st_mode, it's a 16-bit integer, and this MSB 4 bits contains the file type. And going to the bit level and extracting the determining the file type is difficult. Hence the system has supported it with different macros. So you can see here this s_is_dir. This is a macro. It takes st_mode as an argument, and it returns true if that particular file is a directory. Right. So if that particular file is a directory, st_is dir returns true, and we need to print D. Similarly, if that's not true, else if it's a regular file. If it's a regular file, we print dash. If not, we check is character. So it's a character device file, we print C. If not, is blk. It's a block device file, we print B. Is link. If it's a link file, we print L. If it's a FIFO, we print P. If it's a socket, we print S, and so on. So here we are determining the file type. So so here you can see we determine the first column on the file type. Next is the permissions, right? 9 column permissions. So in this pink lines of code, we are extracting the permissions for the file, right? So this is very interesting. The st_mode itself contains the permission. The LSB 9 bits contain the permissions, and what we are doing is, see here, say for example, these LSB 9 bits are like this. So what does that mean is, the read permission for the owner is not there, it is dash, and there, 1 means the write permission is there, and then 1 means the execute permission is there for the owner, and then this is 1 for group owner. So group owner has read permission, and write permission is 0 here, so it's dash, and then execute permission is 1. So like this, say this is the permissions of the file. So we need to determine and print this particular string. So if this information is contained here, we need to print the corresponding string in the ls output. So for that, what we are doing is we are taking we are initializing a variable like this. You can see 1 followed by 8 zeros, and then we are performing bitwise AND operation of these two, that is st_mode and this variable. So bitwise AND, if it is 1 and 1 only, then the output is 1, else it will be 0. So here you can see 0 and 1 is 0, right? So so the output we are going to get 0. It means this, as this output is 0, it means that particular permission is not there. Hence we determine and print dash here. Now what we do is, after printing this dash, after taking it as dash, we are going to shift this variable right by 1 bit. So it will be 0, 1 and 7 zeros. So 1, so in the second bit, okay, the second bit, so it will be 1 and 1, 1. So as you can see, the output is greater than 0, so it means that the permission is set, and accordingly we'll extract W here. So this is what we are going to do for all the 9 bits. So let's take a look at the code. So you can see here it's a simple for loop. So I is initialized to 0, and this I is going to run 9 times, and every time we are incrementing the I, right? This is interesting. You can see here J we have initialized to 1 and left shift by 8 bits. So this variable, what you see here, that is J. So we have initialized J to 1 and we have left shifted by 8 bits. So your J will be 1 followed by 8 zeros, right? So and you can see for every iteration of for loop we are right shifting the J by 1 bit. So what we are performing in inside the for loop, we are performing buff.st_mode bitwise and with J. What operation I explained here, right? So you're performing bitwise and with J. So if that output is 1, it means that permission is there, right? So we are, if it is 1, it goes here, right? If it is 0, it goes here, right? So if it is 1, we are copying that permission bit from P. If you remember, P was initialized to RWX, RWX, RWX. So we are copying that particular permission and storing in AP. If this results in 0, it means that particular permission is not set. Then it goes here and it copies dash in AP. So if this result is 1, you copy from P. If this result is 0, you copy dash and store it in AP. So this is repeated for 9 times. This for loop is repeated for 9 times. Every time we are shifting the J by 1 bit to the right and performing the bitwise AND operation. So at the end of this for loop, AP will have the actual permissions of the file and we are printing it, right? We are printing the permission. So now you can see we have printed the file type and the permissions. The next thing in the output of LS is the hard link count. So from the stat buff, we have a member st_endlink which has got the information about the number of hard links. So we simply directly print the number of hard links. So what's next? Next is username and group name. So here we are using getPWUID system call. We are passing the st_UID. So this contains the UID user ID information about the file owner, right? So this getPWUID, it returns a pointer of type struct password, and that struct password has a member called pw_name. That structure has got pw_name, which gives the corresponding name for this UID. For this UID, it gives the corresponding name. So using getPWUID, we are passing the UID as an argument, and we are getting a pointer to struct password. That password has a member name which contains the name. So we are printing that name. So same is the procedure for group ID also. We are passing group ID as an argument to get grjd, right? And that returns a pointer of type struct group, and we are printing the group name that is contained in that structure. So in this way, we print the user ID and username and group name from the user ID and the group ID. So what's next? The next thing is file size. So in the structure, in the struct stat, we have this st_size which prints the size in bytes. So directly we are printing the file size. Next is the modification time. So in the struct stat, we have this modification time here. You can see time, but the problem is it's not in readable format. So we need to convert it into user readable format. So we are taking the local time function. We are passing the modification time. So it returns a pointer of type struct tm. Okay, so even that is not readable format. So using strf time, we are formatting the time. Okay, so this is a formatted function. So you can specify what format you want the time. So there are different format specifiers, and you pass the t, which is returned by local time, as an argument to strf time. You specify the format you want and the size of this string time. So it converts this t into this format and stores it in this string time. So strf time, it takes t, formats according to this format specifier and stores it in the string time, and then you're printing the time, right? So this way we are formatting the time, modification time, using local time and strf time. And the last thing in ls is the file name. Where is the file name? File name is, we have already seen, d_d name gives us the file name, right? So this procedure is repeated for each and every file in that directory. We are reading the directory, we are passing that to stat, and then we are printing that information with respect to that particular file. So this is done for each and every file in the directory, and when we reach the end of the directory, we are going to come out. So this is the ls explanation for your ls implementation. Thank you.